This is video 4.2.2, and the goal of this video is to be able to continue finding trigonometric ratios for using the unit circle definition. So if we're given the sine and the cosine of this angle t, we have to find the exact values of the four remaining trig functions. So first thing, we want to understand our definitions. So remember, sine of t is just the y value, and cosine of t is the x value on the unit circle. So to find the exact values of the four remaining, we need to know their definitions. Remember, tangent of t is the y over the x, like the slope. So we're simply going to put the y value over the x value, 2/5 over square root of 21 over 5. Now we'll simplify using our understanding of fractions by changing the denominator to multiplying by the reciprocal. So we'll do 2/5 times 5 over square root of 21. Simplifying that, cancel the 5's, and we'll get 2 over square root of 21. But of course we have to make it proper and give an answer of 2 square root of 21 over 21. So that's how we'll find the tangent of t. So the next ratios, we'll continue to use our definitions. The cosecant of t will be the reciprocal of sine. So we're simply going to take 2/5 and take the reciprocal of that, and we get 5/2. Secant of 2 will do something similar, but of course we'll use cosine. The reciprocal of cosine in this case is 5 over square root of 21. Making that proper, we get 5 square root of 21 over 21. Last but not least, cotangent. Cotangent, remember, is the reciprocal of tangent. So we'll take the tangent value, and we'll take the reciprocal of it. But notice, since we had made that proper, the previous expression, 2 over square root of 21, will be a better expression to use, because if I take the reciprocal of that, I'll get a quick answer of square root of 21 over 2, without having to make it proper. So now, those are the 5 trig ratios for that particular problem. So, next example. So now we're given the sine of the angle is 3/5 and that the angle is between 0 and pi over 2 radians. We have to find the exact value of each of the remaining 5 trig functions. So this one will be good to draw a picture for, because we want to see where this angle is. Keeping in mind that sine of t is the y value, so that's and where the angle appears in quadrant 1, because that's between 0 and pi over 2. We'll draw a picture knowing that we have the y value of 3/5. The radius is 1, so the hypotenuse is 1, and the x value is what we do not know. Now what we'll do is solve for the x value by using the Pythagorean theorem, because this is a right triangle with a height of 3/5 and another leg of x. So we'll set up our Pythagorean theorem. 3/5 squared plus x squared equals 1 squared. Solving for x, we will start by squaring each of the values, and then we'll subtract 9 over 25 from both sides. Of course, we need common denominators to subtract, so we'll have 25/25 over 9 minus 9 25ths, which will give us 16 25ths. Last but not least, we'll square root that, and we'll get 4/5 for the x value. So now that I have the x value of 4/5, I can find cosine, because cosine is just the x value. So the cosine of t is 4/5. Now I got to find my other trig ratios. That's 1. I need 4 more. So I need, let's see, secant of t. That's the reciprocal of cosine. So that's 5/4. Cosecant of t is reciprocal of sine. So I'm going to take 3/5 and flip it upside down, and I get 5/3. Tangent of t, well, that's the ratio between y and x, or the slope of this particular line. So I'm going to do 3/5 over 4/5. Simplifying that by using the idea of multiplying by the reciprocal, I'll cancel the 5's and get 3/4. Last but not least, cotangent will be 4/3, because of course that's the reciprocal of tangent. So those are my 5 trig ratios. Now the next examples are finding values of trig functions that aren't on our picture, on our unit circle. So what we're going to do is we're going to find 9 pi over 4 by knowing first that the full circle is 2 pi, and knowing that this is bigger than 2 pi. 8 pi over 4 is a full circle of 2 pi, and so that I go an extra pi over 4 to get 9 pi over 4. If you look again, that's a full circle plus pi over 4. So this value will be the same as the sine of pi over 4, which is just square root of 2 over 2. Tangent of negative pi over 4, the next problem, is going to be found by finding the negative 5 pi over 4. So I'm going to go back negative 5 pi's over 4. So there's 1, 2, 3, 4, 5. There's negative 5 pi over 4. Tangent is just y over x, so I'm simply going to do y over x. But this value is going to be the same as the tangent of 3 pi over 4, note, because that's a coterminal angle. And if we remember, when we put these two fractions over each other, y over x, we're going to get negative, because one's positive, one's negative, and it's going to be negative 1. So the tangent of this value is negative 1. Last but not least, we have cotangent of 5 pi over 4. So again, we have to find the angle on our trig circle. So 5 pi over 4 is there. We see that it's x over y. And we see that it's going to be negative square root of 2 over 2 over negative square root of 2 over 2, which is just 1. Hopefully you remember that there's another angle that has a tangent, that has a cotangent of 1. Now, how can we do these a little bit quicker rather than finding these angles? Well, here's what you need to know. Periodic properties of the values. Sine, cosine, and of course cosecant and secant are periodic in that they repeat every 2 pi. That should make sense because you rotate a full circle plus the angle theta that you normally would have done. This is how we find coterminal. So coterminal angles, of course, have the same sine value. Tangent, though, is nice because it does repeat every 2 pi, just like the others, but it also repeats every pi. So take a look at this picture so you can understand that. Here's a pi over 3. Now, if I extend that line, I see that 4 pi over 3 is a pi away, and it has the exact same tangent value, because look at those lines are exactly in line, they have the same slope. So those two values will be the same. So these periodic properties are what I would say they're nice to know right now, but they're a need to know later in the trimester. So it's nice to know this because we'll find values a little bit quicker, and we'll talk more about that in class. Here's your free response and your multiple choice questions. Do your best on these. For the cotangent, you're finding the cotangent of negative 11 pi over 4. So bring those questions into class and we'll go over them. Also submit this in the Google form, please, so I can give you feedback and know who understands this and who doesn't before you even enter class. See you tomorrow.